Everyone, today we're starting a different type of calculation, and this is called a solution calculation. You'll find this on page 93, hopefully in your booklets. If the pages haven't jumbled up again, it should say the title at the top of the page, Solution Calculations anyway, so double check it there. Now we're starting off looking at concentrations of solutions. That's the first thing. In year 11, we looked at the equation to calculate moles. And we learned all about moles, and we realized that mole is just a unit of measurement in chemistry, and the mole is 6.02 times 10 to the 23 particles. So if you had 6.02 times 10 to the 23 particles in a solution or in a compound or in a solid, then you had 1 mole. So remember, those are the two numbers that match there. But when we're using solutions, and you'll know that when we use acids and alkalis in the lab, that these always have concentrations. And in particular, when we looked at the rate of reaction experiments and we looked at how concentration affects the rate, you notice that the bottles had different numbers on them. Like we had 0.25, 0.5, 1.25. So those were the concentrations. But in chemistry, we have to be able to calculate the concentrations from the knowledge we've been given. So that's what we're going to look at today. And by the end of this, you should be able to do that very, very confidently. So stay with me and let's get this done. Hopefully you will notice at the bottom of each of these slides, I'll have the page number in case you get lost. So we're still on page 93 and we're at the top of the page. Here what we have on this slide is we've got the equation triangle that we've learned from year 11. So the moles equals the mass divided by the formula mass. Remember, that's AR if it's an element, or it's MR if it is a compound. Okay, and you'll also hear people talk about it as RAM for an element or RFM for a compound. So we know that very well. Moles equals mass divided by the formula mass. So all the mass numbers added together. At the top of the page, though, there's this sentence, okay, and it's for solutions, so that's why there's a little solution there, because this triangle that you see in front of you applies to solids. We have to have a different calculation when we're looking at solutions. So looking at the top, it says solutions are slightly more complicated than solids because the number of moles depends on the volume. So write volume in there. The number of moles depends on the volume of the solution in centimeters cubed and on the concentration of the solution in moles per decimeter cubed. So with solids, when we were calculating moles, all that mattered was the mass of the solid and then the mass numbers of whatever was in that solid. With solutions then, what matters is the volume of the solution and the concentration of the solution. That will affect our moles. So it's very, very important that we keep that in mind. Solids and solutions are different. They need different calculations. Just below that then, reading on, it says a solution that has a concentration of 1 mole per decimeter cubed. I want to stop there, okay? Mole per decimeter cubed is the unit for concentration, okay? Mole is obviously mole, but decimeter cubed is equivalent to 1 litre. It's just a different way of writing 1 litre. And we know 1 litre is 1,000 centimetres cubed, also known as 1 decimeter cubed. Okay, so reading from the start, a solution that has a concentration of 1 mole per decimeter cubed has 1 mole of the solute dissolved in 1 decimeter cubed of the solution. So if you go to that solution, what you'll find is if you have 1 litre of the solution, there'll be 6.02 times 23 particles of the solute dissolved in that. Next sentence. If you had 500 centimeters cubed of a solution of concentration 1 mole per decimeter cubed, you would have 0.5 moles of the solute in that volume. Let's look at this a different way. Here is the beaker, and it is a 1 litre beaker. So I could say there is 1 decimeter cubed of solution in that beaker. Now, in that 1 decimeter cubed in this beaker, I have 6.02 times 10 to the 23 particles. Shorten that, simplify it. That means I have 1 mole of particles in 1 decimeter cubed of this solution. So the concentration then is 1 mole per decimeter cubed. Because solutions rely on different things to solids and therefore need to be looked at differently, we have a different equation, and you'll see there on page 93, you have a rectangular box about halfway down the page. What we're going to write into that is the equation we now use when we're working with solids. So this we use if we want to calculate moles, or if we want to calculate concentration, or the volume of the solution, depending on the information they give us. Remember our units here. The unit for moles is MOL, mol. For concentration, we've looked at just in this video a couple of minutes ago, is mole per decimeter cubed. Very important you have a -3 above that dm, okay? And then volume is usually given to you in centimeters cubed. And so, because we have a difference in this centimeters cubed and the decimeter cubed here in this, we have to divide by 1,000, okay? So when you're doing this type of calculation, double check your units that they're right. So moles should always be in mol, concentration should always be in moles per decimeter cubed, and volume should always be in centimeters cubed. Write this equation into the box as well as the units, because it's very important that you have all that to use and to learn and to work from. I think we could talk all day about how you would approach these questions, but until we do it, we're just going to get more and more confused. So we're just going to look at an example straight away, because this actually is a really simple question to answer. So example 1 on page 93. 1.4 grams of potassium hydroxide were dissolved completely in 100 centimeters cubed of water. Calculate the concentration of the solution formed in moles per decimeter cubed. I've also put up the exam tip there, which does your conversions for you to remind you that 1 decimeter cubed is a litre, 1 centimeter cubed is a milliliter. Sometimes we can get confused there. And 1,000 centimeters cubed is 1 decimeter cubed. I want you to visualize this question. I think it's easier. I know it's easier for me when I try to visualize what I have. So the question says we have 100 centimeters cubed of water. That's what we've started with. Imagine that's in the beaker. You've got 100 centimeters cubed of water in the beaker. What has been put into that then is 1.4 grams of potassium hydroxide, and that's dissolved. So now we have a solution, and we've been asked to calculate the solution. And there's a few steps. So step 1 is to find the moles of the solid added. We started with a solid, so let's find out how many moles were actually put in. So you can do that very easily because it's a solid. You're using the calculation moles equals mass divided by MR. And it's MR here because potassium hydroxide is a compound. Let's look at the mass we have. We've been told we have 1.4 grams. And the MR then is going to be the mass numbers of potassium hydroxide added up. So potassium has a mass number of 39. Remember, you find this on the periodic table. Oxygen has a mass number of 16, and hydrogen has a mass number of 1. So we add them up, and that gets us the MR. So our next line in our calculation is 1.4 divided by 56, because 39 plus 16 plus 1 gives us 56. Do that calculation, and you find the moles of potassium hydroxide added were 0.025 mol, because there's our units. Okay, so that's step 1. Moving on to step 2, because we haven't answered the question yet, they have asked us for the concentration. They initially gave us the volume, but they didn't give us the moles initially, so we had to work them out ourselves, and now we're going to work out the concentration. So we're going to use the equation that we looked at above in the box. Okay, so step 1's been done. We know that there's 0.025 moles of KOH in 100 centimeters cubed of water. And now we need to find the concentration. So the first thing we're going to do here is write down our equation from the box above, and that is moles equals concentration times volume divided by 1,000. Now, we want to find the concentration, so we've got to manipulate this equation a little bit to have concentration by itself instead of moles. So let's change this around. What's going to happen here is the 1000 that is below, I'm going to move that over to the left because I want to get concentration by itself. So it's going to move over to the moles. So instead of being divided by 1000, it's going to be moles times 1000 equals concentration times volume. Now, concentration is not by itself yet, so I have to do another step. I'm going to take volume and I'm going to put it over the other side. It's going to change sign. Instead of being multiplied by, the opposite of that is divide. So it's going to be moles times 1000 divided by volume will get me concentration. So this is the calculation I have to do to get my answer here. Now I've just moved that final equation up to give us more space, and I flipped the two sides around. I find it easier to have the thing that I'm looking for on the left, and that's just habit. So you don't have to do that. I just find it easier. What I want to do before I put my numbers in is I want to double check their units so I can see moles is in the right units and volume is also in centimeters cubed that I need. So I'm going to put my numbers in. So concentration equals 0.025 times 1000 divided by 100. Do this calculation in my calculator, don't do it in your head. And I get 0.25 times 0.25 moles per decimeter cubed. Okay, so that's your answer. Concentration equals 0.25 moles per decimeter cubed. Now, I know you have that example already as a worked example in your book. Use that to help you when you're answering these questions. And, use this video again and again if you need to help you with these questions. Let's look at page 94 now. Looking at example 2, this one you have got to write in. So this is your worked example. You can see that I staggered it out, that you're going to do step 1 on the left and step 2 on the right. For these examples, you have to do step 1. Sometimes you won't have to. Sometimes they'll just give you the moles. So all you'll have to do is step 2. So it's your job to look at the question, figure out what information they've given you and what you've then got to find out. So let's look at the question. Calculate the concentration in moles per decimeter cubed of a solution formed when 3.75 grams of hydrated copper 2 sulfate are dissolved in 75 centimeters cubed of deionized water. So let's imagine this. We've got 75 centimeters cubed of water. The fact it's deionized or not doesn't matter. They've put that in to throw you and make you panic. It's just water. Deionized, distilled, plain water, they're all the same thing. Okay, so 75 centimeters cubed of water. And what we've put into that is 3.75 grams of hydrated copper sulfate. Now we've been asked to calculate the concentration, so looking at the equation on page 93, we need to know the moles and we need to know the volume. They've given us the volume, but they have not given us the moles, so we've got to calculate that in step 1. Remember, to find moles of a solid, it's just mass divided by MR because it's a compound here. The mass then is 3.75 grams, as they have told us, and the MR, we're looking at the formula to find. So looking at the formula here, we can see copper with a mass number of 64, sulfur with a mass number of 32, then we've got 4 oxygens. Each of those oxygens has a mass number of 16, so it's 4 times 16. And then we've got 5 waters. Water is made up of 2 hydrogens and 1 oxygen, so 16 plus each of those hydrogens, which are 1, is a total of 18. So we've got 5 18s. Take this and add it together and you will get your MR. So looking back to step 1, moles equals 3.75 divided by 250. And again, do all this in your calculator. You're allowed to bring your calculator in to any test or any exam in chemistry, GCSE. So make the most of it. Don't do it in your head and stress yourself. So 3.75 divided by 250 will get you 0.015 mole. Copy this now under step 1 before you move on to step 2. We can summarize there then that 0.015 moles of copper sulfate is in 75 centimeters cubed of water. That's the information we need to calculate our concentration. Looking at step 2 then, we need to find the concentration. Again, you might want to write out the original equation, so moles equals concentration times volume divided by 1,000, and then you might want to go through the steps here to get concentration by itself before you move on, okay? Or you might just want to write the version which has concentration by itself already. Now we have the equation in its right format. What we can do is check our units on our information and put that into our equation. So looking down at the bottom, you can see moles is in the right units, as is volume. So we can just put them into our equation straight away. So concentration equals 0.015 times 1,000 divided by 75. Do the calculation in your calculator and you will get the answer. Concentration equals 0.2 moles per decimeter cubed. And that's your final answer. Now we've done the two examples, what I want you to do is I want you to work through page 94 to 96. Okay, so there's questions to practice this on page 94 to 96. What you need to do is just check every question to see exactly what you need to find. You might not need to find the moles, you might need to find the moles first, and you might need to check your volume and change it to centimeters cubed, things like that. Take your time when you're doing this. This is all I'm asking you to do in today's lesson, so you still have plenty of time to get this done. I want to look at the first three questions there, just to point out a few things that I'm talking about here. So question 1, calculate the concentration of a solution in moles per decimeter cubed that contains 0.24 moles in 250 centimeters cubed. They have already given you the moles, so you don't have to do that step 1 we've done before, and your volume is in the correct units. So you can just dive straight in and go concentration equals moles times 1,000 divided by volume. Okay, you can go straight into that, write down the equation, put your numbers into the equation, and then do your answer. Remember to put in your units. If you look at question 2 now, it says calculate the concentration of a solution in moles per decimeter cubed, which contains 249 grams of potassium iodide in 2 decimeters cubed. Now, you will have to do the moles step here because they've given you grams. So you've got to do step 1. Moles equals mass divided by MR. Your mass is 249. You have to find the MR of potassium iodide. The formula is Ki. Okay? The formula is Ki. Find the MR of that. The other thing you will have to do then in this question is look at the volume. We need volume to be in centimeters cubed here, but it's in decimeters cubed. So you want to use your little exam tip on the previous page. Remember, 1 decimeter cubed is equal to 1,000 centimeters cubed. So what will 2 decimeters cubed be equal to? Okay, so you've got to watch each question. They'll be slightly different and some will try to trick you. And then in question 3, you can see that calculate the concentration of a solution of sodium chloride, NaCl, in moles per decimeter cubed that has 4.68 grams of sodium chloride dissolved in 50 centimeters cubed of water. So you've got to do step 1, convert the grams to moles, but in this one, the volume is okay. So make sure you check these all really, really well before you get going. Okay, so complete page 94 to 96. Take your time. Look out for if you've got to convert to moles or not. Look out for your volume to make sure it's in the right units. And remember, you're looking for concentration in each of these. So your unit at the end should be moles per decimeter cubed. Once you're done, upload this as a PDF or pictures in a Google Doc. If you're really struggling, give me a shout. But I want you to look at those 2 examples we've gone through. Use them to help you. It'll be really repetitive after a while. You'll be doing the same thing over again. Okay? Once you get this sorted though, it's all downhill sailing from here. It's easy peasy after that. Okay? Take care, folks. Be in touch if you're stuck. Bye now.